Hi, I'm Justin. Wait, what? We're not starting?
Well, let's wait for a little more people first,
All right,
because we just started, right?
No, please join.
Okay, so do you want to introduce yourself first?
Alright then, hi, I'm Justin.
And I'm Caitlin, and we're from the FTC robotics team, Pr0Teens.
In partnership with Best Buddies, today we're bringing you a series of fun STEM experiments that you can do at home.
Yeah, and today is our second experiment, and last week we made this
air blaster cannon, or air vortex cannon.
Yeah, and if you missed this, you can go check it in our Instagram page, and we will have the recorded live. And today, do you want to show?
We'll be making a Popsicle Stick Catapult. It's a really simple experiment that you can probably do at home if you have popsicle sticks lying around and some rubber bands.
Yeah, and we're going to start right now by explaining what materials we're going to need, right? So,
alright then. So you'll need 10 popsicle sticks.
Yeah, first we'll need, can we show?
10
jumbo popsicle sticks.
We'll need some rubber bands. 1 bottle cap, like so. And obviously, I'm going to have some tape to hold it together. You can use some extra strong duct tape, or even, some strong thinner tape can work as well.
Okay, so for our first step, do you want to show the first step?
Alright, so you're going to make 2 notches into your jumbo popsicle sticks that look kind of like this. 2 notches on either side. Because we're going to be putting rubber bands around those later on. So if you notice, they'll fit like this into those notches. So let's start cutting them.
Yeah, so we'll make one one popsicle stick will look like this. Like, it'll have notches on one side, and then we'll make the same one of this. We'll make 2 of these popsicle sticks. So, and to be sure to leave a little bit of space at the top, and then now we can start showing you how we're gonna make it. So,
I'm gonna carefully try and cut 1 notch up there, and then we'll cut another one below it.
So, to summarize, it's basically you make 2 cuts on the top of the popsicle stick, and then you can kind of just pull out the wood, the popsicle stick, and then you'll make a notch.
There you go. You'll have 2 notches like that, and you're gonna want to repeat it on another popsicle stick and try to have them roughly around the same general area.
Yeah. So you have to make sure it's like around the same length, and you can use a pencil to mark it out or something. Or you can also just eye it.
Nice cutting, guys.
Yeah, you want to introduce yourself?
Can I come with the camera?
Okay, sure.
Alright,
So
this will be our next
What's up,
year's
guys?
head of programming, Jason.
Yeah, he's also part of our robotics team.
Try to tell them a little bit about yourself.
I'm Jason. I'm in grade 11. I wasn't supposed to be here, but I am. But I'm the head programmer next year, and I really look forward to doing that. So I'm just kind of here chilling with these guys.
Yeah, he's helping us with our lives. So
Yeah,
now if we want...
Right. So now afterwards, we're gonna take these 2 popsicle sticks.
Yeah, and this is what our popsicle sticks. Yeah, this is what our popsicle sticks look like.
And so then you're gonna take afterwards your 8 remaining popsicle sticks.
We're gonna take these 8 jumbo popsicle sticks and we're gonna stack them together to make a pile, like shown here. This is 8 popsicle sticks together. So we're gonna make a pile of 8 popsicle sticks.
So you're gonna wanna do one end first.
Yeah, so see, this is our pile. And then now we're gonna tie one end
Put
together.
the rubber band over that end. You can just twist the rubber band around it multiple times to make sure that it stays in place. Oh. That should be good.
Yeah. And then now we do the other side.
I twist the other end as well. Make sure that both ends are very tightly secured so no popsicle sticks fall out. Right?
So now this is what it'll look like. It's our pile of 8 popsicle sticks. And then if everybody is done that, we're going to move on to our next step where we're going to take one of the notched sticks and then we're going to slide it under the first layer of the popsicle stick pile. So we're going to take the first popsicle stick and then we're going to slide the notched one underneath like this. And we push it through.
I'm going to try to leave as little space on the edge, just like a 1 finger's amount space between the notch and the jumbo popsicle stick pile.
Yeah, and so the notch will be on the shorter end, and then the longer end will be the side without the notch. And then once we're done this, we'll flip this upside down.
And we're going to take the other popsicle stick that has the notches in it, and we're going to place it on top of this pile. Try to pinch the two ends together. If you need some help, you can ask a parent or guardian for assistance.
So this is what it'll look like from the side. And then now we're going to tie the notches together.
With the rubber band, so you're going to try to get the rubber band into the grooves of the notches.
And this is where like
around a few times.
Yeah, and this is where the notches come in use. Like it helps secure the rubber bands and prevents it from falling when we're launching the catapult.
So this step might take a bit of time. Try to make sure that none of your rubber band lines fall out of the notches.
Yeah, and we have to make sure it's tight because this is the part that will give us most of the power.
Tension or potential energy, which will be explained later on into this live how that actually works.
Okay.
So that should be good.
Okay, so once that's secured, you'll see that the catapult will start taking shape, and this is what it'll look like. And then we can adjust like the length of the popsicle sticks, like push it in a little bit, and like the rubber bands. Then after we're done that, our next step is
to attach the bottle cap.
So this is our bottle cap. It can just be like any bottle cap from like a drink, but like bigger bottle caps are also are better for this experiment because we're going to be launching objects. So there's a more like you can fit like more objects in it. So
now if you have some like pre-cut piece of tape like we do here, you're gonna take those pieces of tape and you're gonna attach your bottle cap onto the catapult end, the one up here. So
yeah, so it's
going
gonna
to
be the
so it'll look like this.
Yeah, and this is not the end that's inside of the popsicle stick pile, but like the end that's connected and diagonal here. So we're gonna tape that
Attach
on.
the end, tape that on over here, and then we're gonna tape it on over here. Try to make sure
it doesn't
that
matter
the
if you
end is
use
secured.
like glue or tape or like hot glue, as long as you can secure the bottle cap onto the popsicle sticks, it'll be fine.
All right. Now that we've done that, you now have finished your catapult.
Yeah, this is basically it, and then we can try testing it out by launching some objects.
So, for example, now we can try to launch, let's say, whoops, almost fell there. So for now, we can try and launch, for example, let's say this wad of tape over here. If you'll notice, it can go quite far. Just glue that, I think.
Okay, do you want to show again? Like this is our catapult, and then we place the object inside the bottle cap over here, and then and then we can push down the arm. We push down the arm. We push it down. It'll launch the object and it'll fly. So that's basically what our final project is. And then you can try testing it out with different objects, and you can see which ones go farther. And you can test it out with. As we said in the Best Buddies post before, that there are many different power that you can use, like pencil top or like marshmallows, and then you can test like which one will go farther and like the differences between each object, and maybe try to predict how far it'll land and which objects will land farther.
Mm-hmm.
And then so we're gonna explain how this actually works and the science behind it.
Alright, so when you pull back on the popsicle stick, you have potential energy or resting energy, and it gets stored up. When you release the stick, that potential energy turns into kinetic energy, or rather, moving energy. And gravity will eventually pull the launched object back to the ground. So notice here what's basically happening is, when we pull back over here, we're storing kinetic energy in, the rubber band over here. And when we let go, that kinetic energy that potential energy turns into kinetic energy, which is released and pushes our object up into the air, and then gravity will bring the object back down.
Yeah, so that's basically the science behind the catapult and the science of the potential energy and the kinetic energy. And yeah, so I think that's the end of our experiment for today. But next week, in 2 weeks, we'll be having our next series in the lives. And do you want to show what we're gonna make?
All right, so next week we'll be making oobleck, which will require cornstarch, water, and an optional food coloring. So if you look here, this is a bag of cornstarch mix that we got from like any local supermarket store. You're gonna need that, some water, and we're just gonna basically be making oobleck, which is a non-Newtonian fluid. So please stay tuned next week for that. All right then.
Yeah, and also for our experiment next week, it will be kind of messy, so be sure to do like some tablecloth or like wipes beforehand, just in case to prepare. Yeah, and that's basically our experiment for this week. And if anybody has any questions, we'll be happy to answer.
So you can type them down in the chat if you have any questions.
And we can also share some more about our robotics team next year. So, as you see, our robotics team is the
We're both members
Pr0Teens.
of the Pr0Teens. This is our team shirt.
And this is an FTC robotics team. If you're not sure what FTC is, it's like part of First Robotics. And First Robotics is every year for FTC we're given a challenge and we make a robot to play the game and earn as many points as we want. And how does this relate with our experiments? So a robotics team has great relations with like STEM and the experiments of science. Like we usually have lots of calculations that involve like physics or like math. So this is like some of the basics we're teaching in these lives can also be used in our FTC robot. And if you're interested in joining like an FTC team or looking at first teams like the Lego League for younger children, or like for younger students, you can look online or check out the Instagram pages and find maybe teams near you that you can join.
If you're really interested, if you go to a high school or maybe even a middle school, your school itself might have its own FTC robotics team, or if you're really passionate about STEM, you can even go and ask to start your own.
So these are all great opportunities in the STEM field, and we hope you had fun in this experiment this week, and we can't wait for you guys to join in with us next time. And as we mentioned before, we will be having a series of Instagram Lives in collaboration with Best Buddies, and we're looking forward to do our next experiment together.
All right. Have a wonderful weekend, guys.
Bye!